Nth term of a geometric sequence. Geometric sequence. Geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by the common ratio, and this is denoted by small letter r. Let us have examples. Example number 1. The given geometric sequence is 3, 6, 12, 24, and so on. From this sequence, our a sub 1 or first term is equal to 3. Our a sub 2 or second term is equal to a sub 1 times r, or the first term times the common ratio. How are we going to get the common ratio? For us to get the common ratio, we divide the second term by the first term, or the same thing with the third term by the second term, fourth term by the third term. Doing that, we have 6 divided by 3, 12 divided by 6, or 24 divided by 12, which are all equal to 2. Since the common ratio is 2, let us now substitute. Our a sub 1 is 3 times the common ratio 2, so 3 times 2 is equal to 6. Our a sub 3 is equal to a sub 2 times r, which is also equal to a sub 1 times r, or a sub 1 times r squared. By substitution, we have the second term 6 times the common ratio 2, or that would be equal to 3 as the first term times 2 as our common ratio, which is equal to 3 times 2 squared. So 2 squared is equal to 4 times 3, which is equal to 12, because our 12 is the third term in the given sequence. And the a sub 4 is equal to a sub 3 times r, which is equal to a sub 1 times r squared times r, which is also equal to a sub 1 times r cubed. By substitution, we have our third term 12 times the common ratio 2, which is also equal to our first term 3 times the common ratio, so we have 2 squared times 2, which is equal to 3 times 2 cubed. 2 cubed is equal to 8 times 3, which is equal to 24. So our 24 here is our a sub 4 or the fourth term. Using this pattern, we can say that the general rule of a given geometric sequence can be expressed by a sub n equals a sub 1 times r raised to n minus 1. Given the general rule of a geometric sequence, a sub n equals a sub 1 times r raised to n minus 1, our a sub n refers to the last term. Our a sub 1 will be the first term. Our r is our common ratio, and our n is the term number or the number of terms. Example number 2. Given the geometric sequence 5, 10, 20, and so on, let us find the a sub 8 or the 8th term. The given here will be our a sub 1 or the first term, which is 5. Our r or common ratio can be obtained by dividing any two consecutive terms. So we have 10 divided by 5 is equal to 2. The same thing with 20 divided by 10, which is also equal to 2. And our n, or the number of terms here, would be 8, since we are looking for the 8th term or a sub 8. So again, the unknown here would be the a sub 8 or the 8th term. So to find this, we use the general rule of a given geometric sequence, and that is a sub n equals a sub 1 times r raised to n minus 1. So let us now solve. By substitution, our a sub n would be a sub 8 because our n is equal to 8. Equals the first term, or a sub 1, is equal to 5 times our common ratio is equal to 2. Our 8 is again the n minus 1. To solve this, we simplify first using the PEMDAS. So we use 8 minus 1 is equal to 7. Then we have 2 raised to 7, that is 2 times 2 times 2 times 2 times 2 times 2 times 2. Or 2 to the 7th power will be equal to 128. Then multiplied by 5, the answer will be 640. Therefore, the 8th term of the given geometric sequence 5, 10, 20, and so on will be 640.